Hello students, so we are now discussing KVPY SX paper 2021 physics section. So we are now looking at question number 29, which is the ninth question of physics section. So this question says that a dipole consisting of two charges plus q minus q separated by a distance 2a is placed with its center d away from the center of a grounded sphere of radius r. So there is a sphere and the sphere has got a radius r, and from the center of this sphere at a distance d we are keeping a dipole. Now the question doesn't mention that whether d is greater than equal or less than r. Okay, so we have to consider two possibilities in that case. So d could be greater than r, which will result in a case like this. So that is one possibility, and the other possibility is that d is less than r. So I will draw that possibility also here. So in that case the dipole would be situated somewhere here. Okay, now it says that d is much greater than a. That means d is much greater than the distance between the two particles. So that can still happen, like one of the particles. And it also says that the dipole moment vector is perpendicular to the line joining the two centers. So dipole can be assumed to be kept like this, or it can be assumed to be kept like this. Okay, so now the question says the charge induced on the sphere is. Now consider this sphere to be Earth and consider this sphere to be Earth. And now we have to talk about the charge which is induced on the sphere. Okay. So see, one very simple argument that we can give is looking at the symmetry of the situation. Like if I if I ask you to think about this horizontal plane as the symmetry plane, then it is indeed the symmetry plane, and therefore we have no reason to believe that charge in this hemisphere should be more than the charge in this hemisphere. So whatever magnitude of charge appears in the upper hemisphere, okay, right, let me write it as qi, the same magnitude of charge must appear in the lower hemisphere, and the polarity should go opposite. Why? Because here this dipole, this end is positive and this end is negative. So whatever effect we are experiencing in the upper half, the same effect we will experience in the lower half, but with opposite polarity. So therefore we can now say that these two charges must be of opposite polarity, and therefore the total charge will be zero. So in this case it comes out to be zero, and the same argument can be given in this case also. Like going by the symmetry of the situation, we can very well argue that we have no reason to believe that charge in any one hemisphere should be more than the charge in the other hemisphere, and they should be opposite in polarity. Therefore the net charge should be zero, the net induced charge should be zero, and that is indeed the correct answer. So a very simple logic, symmetry, going by symmetry, we were able to prove it. I hope you like the solution, guys. If you haven't heard about Vedantu Iklavya, do Google search about it and discover what it is, because you may just be surprised by knowing what it is. Also, this is a QR code. Scan this QR code to remain updated about any batch that Team Iklavya launches. Uh, uh, yeah, that would be all for now. I'll see you in the solution of the next question.